Hi, my name is Bryce Fudge, and I'm going to be making my YouTube video today for Calculus 2. So the first problem we have here is find the volume obtained by rotating area bounded by y equals x squared, x equals 0, and x equals 10. So first thing we're going to do is we're going to make a graph to show this, and y equals x squared is going to be a parabola. X equals 0 is going to be on the x-axis. And then x equals 10 will be right here. Okay. So then after this, we're going to want to find the integral being shown here in the problem. And we are going to use 10 and 0 because you always do the higher number first and lower number second. And then our function here is going to be x squared, but we have to use the formula that was given to us in class. So we're going to have to put pi in front right here. Sorry about that. And then we're going to have to square this and then dx to finish it off. So from here we have we can put pi in front and then put the integral here, and then here we're going to combine those two squareds. X to the fourth dx. Alright. From here, we're going to take the actual antiderivative of this, take the integral of this, and that, when doing that to x to the fourth, that will give us 1/5 x to the fifth. Okay, and then from there, what we do is we're going to put that 10 and 0 back in, and take the values for those. So when plugging in 10, that will be pi times 1/5 10 to the fifth. So the answer to this, or to this part right here, will be 10 to the fifth results in 10 plus 5 more zeros times 1/5 is 20,000. Multiply that by the pi, and then for this 0 part here, when you plug that in, the resulting answer is going to be 0 no matter what. So take away 0, and the final answer is 20,000 pi. And the answer to 20,000 times pi is going to be 62,831. 0.85. And that will be your final answer for that one. Okay, so the next problem is going to be integration by definition. And the problem is finding the integral from 5 to 0 on 4x dx using the definition. And for this one, we're going to start off by putting the equation in here that we'd use, which is the limit from n to infinity b take away a over n and up here k equals 1 Okay, now that we have our equation written down, what we're going to want is to find our a value, our b value, f of x, and this value right here, x star k. So our a in this is going to end up being 0, b is going to be 5, f of x is going to be 4x, and then x star k, we're going to plug that in with this, and we're going to have 0 plus k b take away a times b take away a over n. There, 0 plus k, plug them in. Put that k in, 5k over n, and that is our final answer for that one. So after this, what we're going to do is we're going to plug it in now, and this is what we've done so far. Now we're going to plug it in. So this is going to be, we're going to plug the numbers in here, which is going to be 5 over n. And then we're going to put this back. Then inside, we're going to just keep plugging in. Okay, and then from here, after plugging in, we can put these together because this is basically 4 over 1, which will result in 20k over n. And let's rewrite that. Limit as okay. Now this is what we have. And from here, what we're going to do is we're going to now pull that off. So just keep the 5 over n. This here. Oh, we're meant to pull this in front, so now it's going to be 20 over n. Pull this in front, leave the k over since that is k over 1. And then from here, we're going to put it back in. Okay, and now we can multiply these together. which will equal 100 over n squared. Put this back in here. Nope, we need to put these for it. After that, we are going to then have to plug this here in. So now what we do is this here, based on stuff that was given to us in class, we know it equals n plus 1, and then that over 2. So then we turn it into that and multiply these together for 2, which from there we can make these cancel out. Limit is now going to stay this, but we can pull the 2 under the 100. We can put these together since the n's in there's one n remaining here and the n plus 1 over there, so the n's can go together, and then plus 1 over 1 can stay the same. These will cancel. And then these stay 1. Or these don't cancel. Sorry. Since it's n over n, same thing. They would become 1. So these are both 1, which is 2. 100 divided by 2 is 50. 50 times 2 would now equal 100 again, and this will be your final answer for this problem. And then the next problem that I have made, for the first thing we want to do for this problem would be writing the actual equation out. That would be d of x, d over dx, c's, integral cosine x to the 4th to 2. And then here would be e t squared dt. Now that we have this, we can solve, and the result of this would be a regular integer. It wouldn't have an x or a t behind it, which means that this would equal, let's call it 42. And the derivative of 42 would then make that 0, because a derivative of any number that doesn't have a variable attached to it is always 0. So the answer to this problem will be 0. This is the work for it. Okay, so our next problem is going to be find the integral from 4 to 0 d of dx, and then e is the power of cotangent x dx. So for this one, let's write this out. So it's from 4 to 0. d over dx e to the power of cotangent x dx. Okay. Then after this, these cancel automatically, and that would leave us with e to the power of cotangent x, and then after that we would just pull our 4 from back in here and our 0 from back here, and then from there let's solve this. E to the cotangent, plug in the 4, and that would equal approximately 2.372 once it's been plugged into a calculator. And then e to the cotangent of x would then equal, this would be plug in 0 here for the x. That would make that 0. This would now be e to the power of 0. Anything to the power of 0 is 1. And then anything to the power is 1. Add those together. Or you're going to subtract actually. In this case, take away 1 will then equal 1.372. And that will be your final answer after subtracting them. And that's the integral. Okay. So for the last problem, you need to create the equation from the word problem again. This would be b, a, and this is your function. So let's put that in. B, a, and then with the equation given in class, we have to put the 1 plus x squared here, and then dx at the end. Plus x squared dx. From here, what we would do is we would pull, so then we'd have to do u equals 1 plus x squared. We're going to use substitution and turn that into u. And then after that, what we do is we're going to want to find du, and du equals 1 plus 2 dx, because this is going to take the derivative of that, which is going to be 2, and dx at the end, divided by 2. And we're also going to subtract 1 from it. And when doing that, afterwards, we're going to have du take away 1 over 2 equals dx. And that's the work so far. Okay. After that, double check this really quick. Yes. Okay. After this, what we're going to do is we're going to plug it back into the problem. Yes, we're going to plug it back into the problem, which would then make it 1/2, because I left this out at the beginning, but there's 1/2 up here that needs to be taken care of. integral from 4 to 2 still. And now we're going to make that substitution in. And then after that substitution, we'll still have that takeaway 1 that we needed to put back in 2. I left those off to the side at the beginning. I forgot to mention that. Forgot to mention that when I was doing it. Takeaway 1, and then we have to put our du in. Okay, so after this, now we take the antiderivative, and this is u to the 1/2. So you can use that to make it easier on ourselves and make it u to 3/2, and then we put the 3/2 on the bottom as well. And that would equal 1/3 over 2 u to the 3/2, and that equals 2/3 u to the 3/2. Let's work. And then after that, we'll bring that down. 1/2 in. And we just 2 right here. 2/3 u to the 3/2, take away 1u. So then from here, I should do this times u. So from here, now we would cancel this. It's been done now. Because that's been done, we just took the integral from it, so we're going to cancel that out. And then after that, we're going to bring that 1/2 down. We're going to bring the 2/3 u to the 3/2 down. Take away 1 times u down. And we're going to compute this from 4 to 2. So these right here were done with x's and not u's. So we're going to need to turn these back in to x's for to compute this. And for this, what we would do is we're going to do 1/2. Then we would put in 2/3 still. U is going to change. And that would turn into, let's see, from there, that turns into 1 plus x squared, because that is what our u was here. And then from there, we're going to put that 3/2 back in from the top. Let me spread this out a little more so it's easier to see. And then from here, we're going to need to subtract that 1 and replace that u as well. To 1 plus x squared, again, from this u right here. See right here. And then from there, now we will put this back in to the problem. And then down here, we're going to actually compute this. Bracket this off just like before, but we're going to plug in those other numbers. And then 4 to the second power is 16, plus 1 is 17. 3/2. We just completed this and plugged in 4 for it. And then we're going to subtract 1. And then that is 17 as well. So 17 times -1, -17. And then from there, we're going to fill this bracket back off. And this 1/2 is going to be for the whole problem since we had it outside. So that it will not be written again for the other side. And we're going to subtract the other side. And here we'll put this again. But this time we'll plug in 2. And 2 to the second power is 4. 4 plus 1 is 5. Bring this 3/2 back down. After bringing that 3/2 back down, we're going to do the same thing right here. 5 times -1 is -5. So we subtract 5 there. Bring that back down. 1/2. And then when we plug this into a calculator, we will end up getting 29.73. We're going to subtract that by 2.45 because when you plug this area into a calculator, you get 2.45. Close that bracket back off. And then subtracting these, you get 27.28. 27.28. And then we're going to leave those in brackets. Bring that 1/2 back down. 1/2 times 27.28 is 13.64 after computing with the calculator. And that will be the answer to the last problem. Thank you for listening. Have a nice day.